Apparently,
Hello, this is Mr. Ferguson. We're going to do lesson 6.4, where we're going to talk about organic nomenclature. That would be the naming rules for the organic types of compounds. So our objectives for this lesson are to name the hydrocarbons from 1 up to 10 carbon atoms, to recognize and use some of the structural formulas and other ways of modeling hydrocarbons, and to use the name of a hydrocarbon compound to predict the numbers of hydrogen and carbon atoms in a hydrocarbon molecule. So let's get to it. So the first thing that we want to talk about is, what the heck is a hydrocarbon, Mr. Hunter?
a hydrocarbon, by its name hydro, would be hydrogen, and carbon will, of course, be carbon. So it is a compound mostly containing only hydrogen and carbon. Are we going to do the equations right now for these as well, or no?
No, I think we'll cover that down here under the alkane, and alkynes.
So that's a general thing for hydrocarbons. Some examples of hydrocarbons are plastic, fuels like gas and oil. Those are your common hydrocarbons. When people talk about trying to get away from burning hydrocarbons as a way to sustain electricity, this is what they're talking about, fossil fuels and such. It's just all carbon and hydrogen chains. They're good for burning. Well, fuels, plastics.
There was something else right on top of
polymer, which is a plastic.
Okay.
Don't really need to rewrite it, but okay. So if you think of it, we'll add it to the end.
Anyway, it's a huge class of compounds that are all made just from those two elements.
And carbon organic chemistry is its own class of chemistry, and its focus is primarily on carbon. So it tells you how important to life these hydrocarbons are.
Okay, so we'd like you to copy down this chart. One of the things that's important in naming the hydrocarbons, because there's so many of them, is to identify how many carbon atoms are in the molecule.
It's similar to your mono-di-tri, except for hydrocarbons, they don't use that. They
have their own prefix system.
Yes, they use meth, eth, prop, bute, pent, hex, hept, oct, non, and dec, and then the rest there are something if you want to learn just because, but you'll rarely see these given to you. So learn those: meth, eth, prop, bute, pent, hex, hept, oct, non, and dec, and you'll be good to go. We will be testing you on those and not the bottom 10. So first of all, I guess after that, we want to talk about a class of organic prefixes known as a class of organic compounds known as alkanes. These are also known as saturated because they contain only single bonds. That means every carbon has the max number of hydrogens. So that's what saturated means. So no double or triple bonds. We talked about those in class a little bit the other day, and how I was pulling on somebody to kind of demonstrate the difference between a single, double, and triple. So these alkanes are saturated, all single bonds only.
So the general formula is C comes first, and then we're going to let N represent any number of carbon atoms from, in this case, we're just going to stick from 1 to 10.
Yeah.
Okay, then the H number in a saturated hydrocarbon, or an alkane, is always going to be 2N plus 2.
Okay, you need to learn that because that's something we expect you to know.
For example, a 6 carbon, if it was C6,
should be H. 6 times 2 is 12, plus 2 is 14.
And its name would be?
Hexane.
Hex, that's the prefix, and then just end it with ane. So this is the suffix, ane.
Yeah, probably write that down for them. All end in ane. Right there. So end in ane. Okay, the next one is alkene. These are not saturated. They're known as unsaturated. And they have a double bond, at least one double bond present. And like before, the other ones end in ane. You can probably guess that these ones will end in ene, E-N-E.
So it's double bond, not box, end.
It ends in ene. And its formula is similar to that of the alkane. It's still CN. But in this case, I just think it's H2N.
H2N. Okay, and that would be if there's a single double bond. I think we'll just stick to that, ones that just have one double bond. So in this case, a 6-carbon one would be C6H12, and it
which
would be called
hexene.
There we go.
So just to change the name. And the last one is an alkyne. So that's also unsaturated, and it has at least one double bond.
No, triple bond.
Triple bond, sorry. It has at least one triple bond. And in reality, chemicals and compounds can have double, triple, single, all in the same thing. But that will come up in a whole different class called organic chemistry.
You're going to love it.
Yeah, I like naming.
Sure.
So triple bond ends in -ine. Y-N-E. And for those of you who are welders out there, you use acetylene, which is actually a triple bound compound. So technically your acetylene should be called acetine.
No, ethine.
Yeah, it's yeah. It's
C2H2.
Yeah, so it should be ethine instead of acetylene.
So it's CnH2n minus 2.
Sounds about right.
So we're going to do some practice on the next page.
So there's 1, 2, 3 equations that you should learn, along with the endings.
And the prefixes.
And the prefixes, yes. All right, next slide. So here we go, some examples. We have propene. Prop is the prefix for
3.
3.
So I know it's C3.
And ene means it is going to be the 2n multiplier for the H. So it's just going to be C3H6. So next,
double bond there.
Yeah, it's a double bond. Next is hexine. Hex is for 6, so it's C6.
C6.
And it's just 2n minus 2 for the number of H's. So C6H4. 10. It's okay.
That's
On
okay.
our last slide,
I was almost ready to write 4.
On the last slide, we multiplied wrong. Lydia called us out on it. It wasn't supposed to be 1.4. It was supposed to be 1.6.
We did some subtraction incorrectly, too, and I got
we did.
Called out on that.
I did as well. Thank you for that lovely conversation in class. Octane is C8.
C8, and it's got the ane, so that's fully
2N
unsaturated.
plus 2.
Fully saturated.
So it would be 18. 8 times 2 is 16 plus 2 is 18. Yay, we can do math. Then C4H6. So it's not saturated because it should be total of 10.
So this is 2n minus 2.
This is 2n minus 2.
So this is 4, so it's going to be bute, because that's 4.
Butane.
Butine.
It's a weird one to say.
That is a weird one. All right, then we have C7H14.
That's twice as the number, so it will be a E-N-E ending. So heptene. It's a very nice T. Heptene.
Okay, so that's about as hard as they get at this level.
Yeah, if you don't know the math for them, it will be difficult. But once you kind of get that under your thumb, you're good to go. Okay, the last one is how we model these things. We will play with these in class throughout this lesson, and especially for geometry, you'll see a lot of modeling. So, modeling molecules, we use different types of modeling. The first type, name is propane, so we'll start there. The molecular formula for propane would be C3, and it's ANE, so it's H, there you go, H8. So the first structural formula, if we were to write it out, we would have to write it out in longhand, which requires some space.
How about I go back to pen?
Yeah, so you would have to write your carbons out. So carbon, line for a single bond, line, and now you have to fill in each carbon's hydrogens. So each carbon should have 4 things bound to it. So this outside one should have 3, center one should only have 2, and then hydrogens, that is, sorry. And then the last one again will have 3 hydrogens.
So that's what we call a structural formula, because it still uses just the C's and H's to represent the atoms. But we put them together now so you can kind of get a sense of how the molecule is built.
Yeah. But that's more in geometry a little bit later. But the first type is the ball and stick model. And that's right down here. It's the most commonly used model that we're going to use. And you can see that, well, there are balls and sticks. Carbon, carbon, carbon. And those white ones there are the hydrogens attached. So that's the ball and stick model. So as I was saying, these are the ones we use the most commonly. And we have a couple sets of these that we use in class. The next one is down here, and it is known as a space filling. And you can see that these spheres aren't really spheres, they're kind of half spheres, or spheres with kind of lobes chopped off of them. Because right here you can see how they connect with the carbon. It looks just like one solid mass. And that's how it would be more like in actual reality.
This is supposed to represent kind of if you looked at it and looked at the electron clouds from the outside, I think.
Exactly.
This is kind of
So
what
this
the
is
molecule
this is
shape
more
would
of
be.
your electron cloud overview, and we do have some, but we primarily stick with using this one, the ball and stick method. And beyond that, I think we're done with you, right?
Right, and so they're all different ways to represent the same molecule.
All right. Have a good night.